So now it's time for Mikael Asplund, reader or associate professor in computer science at Linköping University. And he will present the project CEAS. Is that how you pronounce it?
Yeah, I
Why
guess.
not?
CEAS, I don't know, yeah.
Well, which is about adaptive security to allow new digital services in the energy sector.
Yes,
Please.
Thank you. Okay, so, well, I get some slides, you think? Sorry, okay, right. Okay, good. Okay, yeah, so thank you. This will not just be a presentation, it will also be a Swedish lesson for those who are not fluent in Swedish, because accidentally I realized on the train up that I mixed Swedish and English in these slides, so yeah. No further expense for that. So the project, CEAS, Sustainable Energy with Adaptive Security, is funded by Vinnova. And basically the reason for having this project comes from these kind of problems that fortunately we didn't experience this winter, right? That we got disconnected from the grid and, had to grill our sandwiches on an open fire. We managed, but what happens next winter, we don't know, because we're in a very, very troublesome situation, right? At every point in time, the electrical grid has to balance the demand and supply side, right? And of course, we rely on sort of large-scale power generation for this to be feasible. But there comes a lot of small-scale kind of generation with solar, wind, and all these things, but they are not as reliable to provide the sort of stable kind of electricity that we would like to have. But on the other hand, there is actually opportunities by introducing sort of information technology into the grid and making it smarter, right? So if we can do smart control of both the demand and supply side in the electrical grid, we can actually counter at least some of the bad effects that we get from sort of having an unstable both demand and supply. Basically, some of the things you can do is doing virtual batteries, so aggregating the consumption. So you can do things like, your electrical vehicles, your heat pumps in your home. You can adapt the consumption of the electricity to when you have plentiful of energy, and you can reduce the load in the system when there's scarcity, right? And you can do the sort of same thing on the power plant side, on the supply side. So you can also adapt those things so that you get a better balance at every point in time. And there's a lot of smart initiatives and ideas for how you can do these kind of modern services for the grid. Unfortunately, when we introduce information technology into systems, we get all kinds of other problems, right? We get the hacker paradise. Because these are highly critical systems. These are things that, if they break, everything breaks, every other thing breaks. These are legacy systems, 30-year-old software and hardware running in these systems. You cannot just patch them. And of course, they are running at critical software. You cannot just update the software because you found a bug or a vulnerability. Increasingly, and this is what we're doing in this project, these are being controllable from the cloud because you connect cloud services to these critical systems. And in general, operation technology security is hard. We have 30 years, 40 years of experience in IT security, but in these small embedded devices, there's a lot of difficulties, both organizationally and technically, to protect them. So this project, financed by Vinnova, thank you very much, has 4 partners. Linköping University, that's me, we do sort of research. We have a PhD student working within the project. There is a development company called Energiklustret, which are owned by 5 regional energy companies. So they have a lot of, they basically do the kind of prototyping for these energy companies, looking what are the future solutions out there. Excellent partner in the project. We have RISE, who has extensive experience in risk analysis, and Sectra, who does security monitoring for the energy sector. So it's a really nice consortium working together. We're sort of like half-time, a bit over half-time through the project. So far, we've been working on 2 use cases, sort of developed within the project, or supported by the project. One of them is a virtual battery, utilizing these electric vehicles and heat pumps. And there's a company called Emulate that does very clever algorithms for this. And then flexibility trading with wind power, so windmills, with Tekniska Verken. And we've developed a sort of reference model based on this, an architecture for doing this kind of security analysis that we want to do in the project. And done some interviewing and examined current standards for risk management. And done monitoring services for the cloud for these kind of systems. And also started the work with a new adaptive risk method for these kind of systems. And I will say a bit more about that. So in terms of the risk management, we looked at, of course, the literature both in sort of academia and in the practical sense in the industry. And there is a lot done on risk management for SCADA, okay? There's hundreds of papers. There's people have thought clever things, and we cannot really do much more. But what we've seen is that these new services, when you connect, when you say, for example, I want to do clever trading based on these clever stuff from all these information sources, and I put this in as an engine in the cloud, and I let that control my critical infrastructure, there are risks, okay? So there's an increased complexity with a lot of new digital services and a lot of new dependencies that are introduced that people have no control over. If that breaks, that will lead to this breaking and leading to that breaking. I have no control over that chain. There is an increased pace of change, both in terms of the systems, okay, thank you, 3 minutes, of the systems that are running. I get new protocols, new services, new customers coming in at a higher pace than before, but also the threats, every day there comes new threats, every week I have to adapt. Is my system secure in the current situation? As well as an increased organizational complexity. We focused on the first 2 of them. This is sort of an abstract view of the kind of model we're considering, where you have sort of the traditional kinds of systems with the power grid and the large-scale energy generation services, and then you have the small-scale kind of heat pumps, small solar plants, and electrical vehicles. And they connect to different kinds of both public and private/hybrid clouds. And this is a sort of starting point for doing the risk management. This is a current standard for industrial automation systems, and they have a method for risk management. It is based basically on the old way of thinking about energy grids, and we are sort of trying to make that adapted with cloud, so adding to the standard new cloud zones that are suitable for the kind of situations that we're having, as well as looking at adaptive risk management, because there is no support for that at the moment. And we've actually been inspired in this case by another standard from another domain, which is the automotive domain, where they had the new cybersecurity engineering standard for vehicles. Also looking at some sort of AI-based automated triggering, because that's the idea that you create triggers that allow you to see, here you've done your risk analysis, here is some new things that is happening. You need to start looking at this point in your risk analysis because something changed in your assumptions. And that's basically what we're doing. And we're doing further development on that and evaluation during this spring. That's it. Thanks for listening.